Been asked to take a look at this old Wren locomotive. It's got a 3-pole motor in here. I've already taken the brushes out behind here with springs in there. Got a suppression choke there and a capacitor across the supply rails because it picks up on each wheel. One goes directly to the chassis and the other pickup comes up through here, this black wire, through there to the brushes. Here's the bits I've taken out. There's a carbon brush, another one, not in the best of shape I must admit. And you have 2 springs which hold those in, and then wrapped around that was this magnet assembly. This piece is the magnet and they form the magnetic circuit around the motor, like so. Well, the commutator was a bit dirty, so I took out this bushing and you just undo this nut and then unscrew the screw in there, and that removes the bushing. The pivot down inside here just drops away and you can lift this out. There's a worm gear in the bottom and it's quite straightforward. Now, the one thing I did notice when I put the meter on was that a 3-pole motor has 3 windings, 1, 2 and 3. You can see them here. It also has 3 sections on the commutator separated by these divisions here. And if you regard each one of these windings as a resistor, if you measure between any 2 sections, adjacent sections on the commutator, you should be measuring 2 resistors in series with 1 resistor in parallel. If you look at the commutator, there's a little soldered connection here, and in fact there are 2 wires going away. Each section has a soldered connection and each one has 2 wires going away. They're twisted together up to this point here, and 1 wire from this section of commutator goes to this end of this coil, and the other wire goes to this end of this coil, and that's the same on all the sections. So 2 wires go away from here, they go from here to there where they split. 1 goes into here, 1 goes into there. 2 wires twisted together here, split, 1 goes into here and 1 goes into there. And so you end up with 1 resistor is in parallel with the other 2 resistors in series to each other. If you were to draw out this wiring, that's what you would see. So when you measure between 2 sections on the commutator, you're measuring both ways round. You're measuring both the resistance of this coil, because it goes from here round there and then back to here. So you're measuring that one resistance, but you're also measuring the opposite way. You're measuring from here through this coil, and back to there, back to here. So you end up with 2 coils in series with 1 in parallel. Now if we actually take a measurement of this particular one, so I measure across 2 of the sections of commutator, if you have it set to ohms instead of volts and measure across 2 sections of the commutator, that's 8 ohms. Okay, so if I turn it and go to the next section, 15.8 ohms, which is rather odd. And the next section, 8 ohms. So why is one of them different? Well, that's because one of the coils is broken, and so you can measure one of the coils, you can measure another of the coils, which is the 8 ohms, but when you go to the third position, instead of measuring as you would think, 1 coil in parallel with 2 coils in series, you're not. Because one of them is broken, you're actually just measuring the 2 in series, and that's why that 7.9 to 8 ohms adds up to the 15.8, 15.9 ohms for 2 coils. So then I started to look at the twisting, the wire, to make sure there was no break going into them, and I can't actually see the fault. I've disconnected one end of the faulty coil and tinned its end, and if I make a connection with the end of there, and then the other end of this coil here, the wire comes up there and is connected to that point on the commutator, and it's not connected. So this coil is broken somewhere in its length, or just here somewhere. Now it's a very, very small amount of wire in there that I could get to, because this end is buried underneath all that, of course. So to scrape a little bit of enamel off there to make a contact would be very difficult to prove that it wasn't somewhere in here, between here and here. And they're quite well twisted together, and if one of the wires is soldered, you sort of assume that the other one would be soldered. It looks quite well soldered in there. I don't see why it shouldn't be. So for some reason it does look like this coil is disconnected in there. So a decision has to be made. Eleven. 12, 13, 18, 19, 20. On the 20th turn, it's come off. Now there's a lot more than 20 turns on there, so it's possible I may not even need to reconnect that to get this to run again. Admittedly, one of the poles would be underpowered, and it wouldn't be a smooth runner, but as it stands at the moment it's a non-runner. So I'm going to get in there close to see if I can find that end, pull a bit more off, clean the end off, tin it to get a good connection, and then we'll measure it and see whether I've got continuity through this coil now. One moment please. Wow, that proved to be really difficult. I thought I was just going to find an end poking up, but I had to review the footage of last time, frame by frame at the point when it broke, to work out that it didn't break up here, it actually broke down here. And then using a magnifying glass, I was just able to see there was an end. And I got this rather vicious looking dental probe, the other end of which is sticking in my hand. For some reason they're double-ended. And by just ever so lightly just pressing, I was able to just lift this corner, this end I should say. And from that I'm hoping that I can tease that back round. There it is. Right. With that end, I'm just going to clean it up and see we've got continuity. Okay, we're set to ohms this time, instead of wasting our time trying to measure resistance with a voltmeter. That's that one. And that one. .3 ohms. Okay. So if I then connect this, it says optimistically, to where it should be connected, and you're not going to be able to see this, and then measure across, we've got 5.1 ohms, or 5.1. So if we do some maths, 7.3 ohms in series with 7.8 ohms gives us 15.1. To complete the calculation, we have to add the resistances in parallel, but to do this we have to use their reciprocal value. So that's 1 over 15.1 and 1 over 7.8 is equal to 1 over the final resistance value. 1 over 15.1 is a small number, and add that to 1 over 7.8, which is a less small number. Then divide 1 by the result and you get 5.1 ohms. Well, if this works I'll be surprised. I've got helping hands holding one wire while the other wire is held in place by the rotor. So let's see. Oh, that messed it up. I may have it. What I'm doing is reconnecting the 20 turns that I unwound to find where the fault was. No, I'm afraid it was as I'd feared. It was just the flux that was holding it. So this is take 2. And that didn't work well, did it? Ooh, ooh. No, just don't touch it this time. I have pre-tinned and tried to clean them up as best I can. Might be. Reminds me of fibre splicing, actually. Yep, I think that's it. By Jove, I think he's got it. Well, the battery went on the camera and the battery went on the audio device, so I lost the mic. Yes, what was I saying? I was saying I think I've just about got enough wire now. I could do with a dab of glue just to hold this in place. This has to go up and solder on up there, on that spot there, just here. Yes, you need quite a lot of patience to rewind that, probably more than there is in a hospital ward. Okay, so glue, and then we'll try and work out how much I need to solder that onto there without desoldering the other one. I'm just going to put a bit of Frit stick on. I'm afraid the light's going as well, so depth of field on the video is not brilliant either. So things are going to go out of focus, I'm afraid. Yeah, in my head this went a lot better. Ooh. Yeah, it's not just that the video that's suffering from a lack of focus either. I stopped looking at this yesterday because it got a bit too dark, and my eyes just will not focus there anymore. Try and hook that round behind the blob of solder. But to be perfectly honest, I can barely see what I'm doing. Okay. I'm going to take it back off again. Put it into a place where I can get the soldering iron to it. Put a bit more goop on. Or maybe I won't. It looks incredibly bright on the screen on the camera, but I can assure you it's not really bright at all. Right, I now know that I need to try to melt the enamel, if melt is the right word, burn off the enamel at that point. I can't really see what I'm doing. It's moving. Try that. The other alternative, of course, is to get a sharp craft knife and try to scrape the enamel off. But my worry there, of course, is if I do that, I could very easily nick the conductor, just making it a little bit thinner, and result in me breaking just through vibration at a later point in time. Okay. I really can't see what I'm doing there. Helping hands. The drawback with the helping hands is, although I've got a lens here which helps me by magnifying it, the problem is that I can only look through it with one eye, really, and if I do that, it makes judging distance very, very difficult. And everything's moving. It's a broken part from another repair that I had to do. Let's see if I can. Definitely requires maximum dexterosity. Well, I very carefully, of course, arranged it so that it was hooked round behind the existing wire, and then the first thing that happened was the soldering iron caught it and unhooked it. But I do believe I've reattached it. There's a little bit of cleaning up to do. Got that. probably the old wire there that I can see. Yeah. It is further up. I'll show you that. It's quite a lump there anyway, which is not ideal, but I mean you can see how difficult it is. Now, I don't have Louis Rossman's microscope. Okay. What am I doing? I'm going to just measure now the resistance, set it to ohms, and see what we get. Oh, come on. 5.4. Oh. 5.3. Oh baby. 5.4. So that means that they're all correct. That's square, so that's all right. On there. Screwdriver here somewhere. I got this screwdriver from a guy that was selling off a few old tools that had been donated, and I think it's absolutely gorgeous. Possibly, maybe from a sewing machine. I love the fact that it's got a wooden handle, so does that mean it's going to be pre 1950 at least, because that would be plastic if it was post-war. Right, let me connect this old Hornby controller up. Sparking. Still not right. That's locked solid. I think it's catching on this piece here. Yeah, it is. Quite a lump there. Just a bit concerned. It just clears. These tubes here that the brushes are sat in. It just clears it. If that touches on there, of course, it's going to short out on this side particularly, because this one is connected directly to the chassis. Look down. Whether it was just that when I assembled it, the rotor was possibly just not quite in the right place. It's turning now. Well, there's a certain amount of leeway on there actually. You can assemble this skewed, and that's probably what it was then. In my enthusiasm to get the job done, what I should have done is just centered this, I think. See how we're doing. Will it run? No. I know that Wren locos can be a bit power hungry. Part of the reason it wouldn't run then was because I'd got the valve gear sat. I'd only lifted one end up and it was sat on the bench. Yeah. That sparking, you get some idea of how dark it is actually here.